This is Module 1, Lesson 15. In this lesson, we'll be using place value understanding to decompose smaller units multiple times using the subtraction algorithm to solve word problems. We're going to start with a problem written vertically. 253,421, and we're going to subtract 75,838, and we're going to visualize this with a tape diagram. So we start with our total, and we're going to subtract or take out one piece, and we want to know what's left. So as we've done before, we're going to start by looking at each place value and see if we have enough units to subtract. So we have 1, 1, and take away 8 ones. We can't do that, so we're going to take 110 and make this 11 ones. Then we go to the tens. We can't do that subtraction either. We don't have enough. So we're going to take 100 and break it into 10 tens, add it to the one that's there, so we have 11. We're going to check the hundreds, can't do that, so we need to take 1,000, break it into 10 hundreds, so we have 13. Check the thousands, can't do that, so we're going to take 10,000, turn it into 10,000, add it to the two that are there, now we have 12. The 10,000s, can't do that, so we take 100,000, turn it into 10 10,000s, so now we have 14 10,000s. So in this problem, we had to break units into smaller units to do every single place valued subtraction. So now we're ready. 11 take away 8 is 3. 11 take away 3 is 8. 13 take away 8 is 5. Put in the comma. 12 take away 5 is 7. 14 take away 7 is 7. And we have 100,000 left. So A would be equal to 177,583. And we know that we could check this by adding the two pieces together, and we should get back to the whole. Let's look at another one. Now for this one, we're going to start with 1,000, and we're going to subtract 528. So again, our tape diagram, our total is 1,000. We're taking out a piece equal to 528, and we want to know what's left. Now we're going to show this one with a place value chart. So ones, tens, hundreds, thousands, and we're starting out with 1,000. So since there's 0 in all the other place values, in the hundreds, the tens, and the ones, we know we're going to have to decompose. So we're going to take 1,000 and break it into 10 hundreds, and then we're going to take one of those hundreds and break it into 10 tens, and we're going to take one of those tens and break it into 10 ones, and we're going to show the same thing in the standard algorithm, because what we're doing in the standard algorithm is the same here. We started with 1,000, and we're going to break it into 10 hundreds and add it to what's here. So just like we did here, we had 100, we had 10 hundreds, then we're taking one of those and turning it into 10 tens, just like we did here. Then we're taking one of those, just like we did here, and breaking it into 10 ones. So we have what we're left with is 9 hundreds, 9 tens, and 10 ones, the same as we have here. Now we can subtract. So starting with the ones, we're going to subtract 8. 1, 2, 3, 4, 5, 6, 7, 8, which leaves us with 2 ones. Same here, 10 minus 2, 8 equals 2. Then we're going to subtract from the 9 tens, we're going to subtract 2. And we're left with 7, just like we are here. Then we have 9 hundreds, and we're going to subtract 5. And we're left with 4, same as here. And we don't have any thousands left. So our solution with the place value chart as well as the standard algorithm, A would be equal to 472. Okay, going on. Let's do the same thing, but let's look at it with a million. Minus 345,528. So in a tape diagram, we start with our total, which is 1 million. We've taken out a piece equal to 345,528, and we want to know what's left. So starting way over the millions, we're going to take that one away and turn it into 10 hundred thousands. Decomposing 1 million into 10 hundred thousands. We're going to take one of those and turn it into 10 thousands. I'm going to take one of those and turn it into 10 thousands. Take 1,000, turn it into 10 hundreds. Take one of those and turn it into 10 tens. Take one of those and turn it into 10 ones. So now we can subtract. 10 ones minus 8 ones is 2 ones. 9 tens minus 2 tens is 7 tens. 9 hundreds minus 500 is 400. 9 thousands minus 5,000 is 4,000. 9 10,000s minus 4 10,000s is 5 10,000s. 9 100,000s minus 300,000s is 600,000s. And we don't have any millions left, so this would be our solution. 654,472. All right, let's use this to solve a word problem. Last year, $620,073 people went to a parade. This year, 456,795 people went to the parade. The question is, how many more people attended last year's parade than this year? So how many more problems are common? And we set this up as a tape diagram with the larger value as our total. So last year there were 620,073 people. This year it's lesser number. It's 456,795, and we want to know what this piece is. We want to know what the difference is. How many more? So This tells us we need to set up a subtraction problem. And we need to subtract. So again, we're going to start with our ones. We need to get 10 tens, 10 ones. We can't do the tens, so we need to go to the hundreds. We don't have hundreds, we don't have thousands, so we have to go all the way to the 10,000. Take one of those, make it 10 hundreds. 10 thousands, take one of those and make it 10 hundreds. Now we can take one of those, so we have 16 tens. And then we're okay with the ones, the tens, the hundreds, the thousands, but we need 10,000. And now we can subtract. 13, take away 5 is 8. 16 minus 9 is 7. 9 minus 7 is 2. 9 minus 6 is 3. 11 minus 5 is 6. And 5 minus 4 is 1. So this would be our solution for D. And since we have a question written in word form, we need to answer in word form. 163,278 more people attended last year than this year. And I'm going to do a little quick rounding and estimating to see if my answer that I got made sense. So if I look at my first number here, it's close to 600,000. My second number, it's pretty close. I'm going to make it 450,000 since it's about halfway between 400 and 500. And if I subtract this, I get 150,000, which is pretty close to the actual number. So I'm confident that my answer is reasonable. Okay, let's use this to go on to our problem set. So for number 1, it says use the standard algorithm to solve the problems below. So pause the video and try number 1, 1A. For 1A, I can do the ones, but I can't do the 10, so I'm going to take 100. So I have 16 tens. I can't subtract the hundreds, so I take 1,000. So now I have 15 hundreds. I can't do the thousands or the 10,000, so I need to take the 100,000, turn it into 10 10,000s. So now I can take one of those and turn it into a 10. So now if I subtract, I have 0, 8, 9, and 9. Since 9 minus 9 is 0. So my answer would be 9,980. Okay, pause the video and try B. Okay, for B, I'm okay with the ones. For the tens, I need to take 100. So I have 16 tens. For the hundreds, I need to take 1,000. So I have 15 hundreds. Need to go over here to the 100,000. Make 10,000, take 1 10,000 and make 10,000, 1 10,000. So I subtract now. And I have 91,680. Pause the video and try C. Okay, for C, starting with the ones, I need to take a 10. So I have 11 ones. For the hundreds, I need to take 1,000. So now I have 15 thousands. 1500s. For the thousands, I need to take a 10,000. So now I have 11,000s. For the 10,000s, I need to take 100,000. So now I have 13 10,000s. Now I can subtract 9, 5, 8, 7, 9, 1. So I have 197,859. Pause the video and try D. Okay, for D, I can't do the ones, so I need to take 10 ones and make 11. I can't subtract the 10, so I need to take 100, and now I have 15 tens. Can't subtract the 100, so I'm going to take 1,000. Now I have 14 hundreds. Can't do the thousands, so I take a 10,000. Now I have 11,000s. Can't do the 10,000s, so I take 1. Now I have 13 10,000s. Now I can subtract 4, 7, 3, 7, 6. So my number is 167,374. I'm sorry, 54. Not 300, 574. Let me write it again. 574. Okay, moving on. Try E. Okay, for E, we have all zeros till we get to the million, so we're going to take that million, make 10 10,000s, take one of those, make 10,000s, take one of those, make 10 1,000s, take one of those, make 10 hundreds, take one of those, make 10 tens, take one of those, and make 10 ones. Now we can subtract. No, wait a minute. Let me erase. Let's try again. Okay, let's take 1 million, make it into 10 100,000s, take one of those, make it into 10 10,000s, take one of those, make it into 10 hundreds, take one of those, and make it into 10 hundreds, take one of those, make it into 10 tens, take one of those. Now we're good. Okay, now we can subtract 0, 9, 9, 7, 0, 4. So our answer is, this should be 8. I'm having trouble with this one. Let's try it again. Okay, take 1,000,000. Make that into 10 100,000s. Take one of those, make it into 10 10,000s. Take one of those and make it into 10,000s. I don't need to go any further than that. I kept making that mistake because these are all zeros, so we don't have to go further than that. So 0, 0, 0, 8, 0, 4. There we go. 408,000. All right, try F. Okay, again, I'm going to have to take the million and turn it into 10 100,000s. Take one and turn it into 10 10,000s. Take one, turn it into 10,000s. Take one and turn it into 10 hundreds. Now I'm ready to subtract. 0, 0, 5, 7, 0, 4. And I have 407,500. Okay, going on to G. Pause the video and try that one. Okay, for G, I can't do the ones, so I'll take a 10. So I have 18 ones. I can't subtract the tens, so I'll take 100. Now I have 14 tens. My hundreds are okay. Thousands, 10,000s I can't do, so I'm going to take 100,000, make 10 10,000s, take one of those to make 10,000s. Now I can subtract. 18 take away 9 is 9. 14 take away 6 is 8. 5 take away 5 is 0. 10 take away 8, 10 take away 2 is 8. And 9 take away 9 is 0, and 5 take away 5 is 0. So we're left with 8,089. And pause the video and try H. So for H, I'm going to need to go, I have all zeros here, so I'm going to have to go all the way over to the 100,000s, take 1, make it into a 10, 10 10,000s, take 1, make it into 10 thousands, take 1, make it into 10 hundreds, take 1, make it into 10 tens, take 1, make it into 10 ones. So now I can subtract. 1, 3, 4, 7, 9 take away 9, 0, 5 take away 5, 0. So my resulting answer is 7,431. Okay, going on, it tells us to use a tape diagram and the standard algorithm to solve the problems below and check your answers. So we want to make sure that we're using a tape diagram, we're solving the problem and answering the question. So make sure that you write the answer to the question in a statement, and then we're going to check our answers. And with subtraction, you can check either by estimation or by using addition to check your subtraction. So pause the video and try number 2. Okay, so for our tape diagram, it's where we always start. So our total for the length of the entire flight is 11,472 miles. If the plane has 7,793 miles left to go, we want to know how much it's already traveled. So we want to know what the missing piece is. So we're going to set this up as a subtraction problem. We're going to check our units. Can't do ones, so we're going to take 110 and make that 12 ones. Can't do tens, so we're going to take 100 and make it 16. Can't do hundreds, so we're going to take 1,000. So now we have 13. Can't do the thousands, so we're going to take a 10,000. So now we have 10. So now we're going to subtract and get 9, 7, 6, 3. So T would be equal to 3,679. So we have to go back now and answer the question. How far has it already traveled? That's our question, so we need to answer. It has already traveled 3,679 miles. So we've answered the question. Now we need to check our answer either with estimation or with using addition to check and see whether or not our subtraction is correct. Let's round to the nearest thousand. So we'd have 11,000 minus 8,000 would be 3,000, which is very close to our actual answer. So 3,000 is my estimate. And it's close to my actual answer. So my answer is reasonable. Okay, moving on. Pause the video and do the same thing for number 3. Okay, so this is one of those problems where we're comparing to, and we want to know how much more, how much less. So we're going to set up tank B as the larger value in our tape diagram. And then tank A is a smaller amount. And what we want to know on our problem is what's left, or how much less. So we want to know what this extra piece is that makes the difference between tank A and tank B. So we're going to set up our subtraction. Okay, so I can subtract the ones, the tens, the hundreds. Can't subtract the thousands. There's no 10,000, so I need to go to the 100,000s and make 10 10,000s. Take one of those and add it to the thousands. So now I have 15. So now I can subtract. So L would be 227,367, and I need to go back and answer my original question. Tank A holds 227,367 less gallons than tank B. Always have to answer our question. And again, let's do a round and estimate. Our first number is about 900,000. Our second one is about 700,000. 900,000 minus 700,000 is 200,000, which is very close to the number I got. So my answer is reasonable. And finally, do the same thing with number 4. Okay, again, this is a comparison one. So the larger of the two amounts is his bank account, which had $26,000 in it after he deposited his paycheck. Then what he had in his bank account before he deposited his paycheck was $25,081. And so we want to know the difference between what he had on Friday. This is his paycheck on his bank account on Friday. This is his bank account on Thursday. So we want to know what this difference is. So we'll call it P for paycheck. So let's set up the subtraction. So we had 26,010 on Friday. He had 25,081 on Thursday. So let's subtract. So we'll make 10 ones. There's no hundred, so we need to take 1,000. We need to take one of the hundreds. So we end up with 929. So his paycheck is $929. So we need to answer that question. Mark's paycheck. was $929. And this time, let's check with addition. So if we add what he had in his bank account on Thursday, plus what we calculated to be his paycheck, then we should get back to what his final account was on Friday. And we do $26,010. So our answer makes sense. And that's the end of lesson 15.